All right, this is Mr. McMurray again. Now you can't see me. I have this ball. It looks to be basically a white ball if you look at it, but actually it's shooting out and rotating different colors. Let me swing it here for a second. And if you notice that, you can see the different colors. It's red, green, and blue, which are together make white light. Now, the thing is, they're blinking very quickly. I got like LED lights, and they're blinking very quickly. But our eyes cannot adjust that quickly, so we see red and then green, and we put all those together, and it makes it look white light. But when we spin it, then it can separate it out enough that you can see that it's actually different colors at different parts of the circle there because it's moving fast enough that it separates them so they're not overlapping each other. And you can actually see that it is actually three colors. And so white light, we said, is actually three colors, R, G, and B. And we see color by how we see those colors. Okay? And we have little cone receptors, like I said, in our eyes. And for most people, they work pretty good. Mine, not so good sometimes. Okay? Now, we also have a laser. We'll talk more about lasers next month. Oops, I don't mean to blind anybody. All right, this here is a uh, clear plastic rod, and I'm going to turn the lights on because it's taking a while. I think you'll be able to see it once I turn this on. And if I put the laser in one end of it, you can hopefully see as it goes through the light. And you can kind of see, especially up there at the curve, you can see where the light beam actually gets rotated different directions, okay? And if I face it toward me, then it comes out the end of the uh, hose basically toward me. And so this is a clear plastic rod, and this is kind of how fiber optics work. They have what we call total internal reflection, which means all the light gets reflected back inside. It doesn't, very little of it escapes. And this is how they make fiber optics that carry signals using light instead of electricity. You don't have the resistance and problems that you have when you're going through the wires of with electricity. And so it works on the principle of total internal reflection where all the light gets reflected so it stays in it. Now, it also would have coatings around it on the outside to help that. But basically, that's based on the idea of reflection as well. But it's a total internal reflection. Almost time for Christmas. So we have some Christmas tree lights. Over here we have the white lights. It's just like a big blur probably. And over here we have different colored lights, okay? And what we're going to do is take a filter. We talked about what color things are, but really what color things are depend on what color of light you see it through. So I'm going to put a blue filter on this. And you'll notice that the white lights are still visible. But they're only letting through the blue light that's coming from them. The filters are kind of like pigments. They absorb all but one color, and they only allow the blue through. But if you look over here at the colored ones, you notice they were much more light. And I'll put this there. The ones that were blue still come through, but the green and the red and some of those other colors are almost invisible or very, very dim. Now, notice they don't go completely out, which means that they must have some blue light in them. Most colors, we say it's blue or red or whatever, actually have a combination of several colors of them, but the dominant one might be red or green or blue. And remember, you have to combine those three colors in different amounts to make all the other different colors that there are. So there are in betweens. Okay, if we put a red filter there, once again, the green one, the white ones over here are still showing up pretty good, but the blue ones over there, yeah, they get dim a lot because the red lights show up, but really, to be honest, almost all the other lights go completely out. Okay, so the blue lights and the green lights apparently have very little blue in them because you don't see hardly any of them after that. Okay, and then last, of course, we have the green filter. So stick it over, once again, the white lights, you can still see them. All of them show because all of them have green light in it. But on the other side, you'll notice that quite a few of them dim down. You can still see the green lights pretty good, and you probably see a little bit of some of the other lights, but it definitely makes a really big difference in how much of them show up. And so, if the light that you're looking at things with do not have all the colors in them, then that's going to make objects look different colors. Objects are not a particular color. They are only, we see the colors that are reflected from them. But if all the colors aren't there to be reflected, then we're not going to see those colors. And so that may affect what the color looks like. Some says, well, what difference does that make? Well, we're going to try to show this, but I don't know if I'm going to be able to do this, but I'm going to try it. Okay? All right, we're scientists. We experiment, right? So we're going to try to look at the light fixture up here. Okay, and I'm going to try to put this on it. I don't know. Oh, there we go. Not bad. Okay, so off to my right. I don't know on your side. Oops. There we go. You can see the bright light. That's the fluorescent light bulb. And off to the right-hand side, you see these little bars of color. Now, I don't know if they're accurate on yours, or they may be reverse order, so it may be the bluish color first. But you will see those different colors. And rather than, if we did this outside and you looked at the sunlight, you would just see a solid color going from red all the way orange, yellow, green, blue, indigo, violet, all the way through the whole color spectrum. But if you notice there, you just saw certain bars. So there are certain wavelengths of light that are not present in fluorescent. And so if you pick out a paint sample under fluorescent light, you're only seeing some of the light reflecting off of it and being absorbed and reflecting off of it. And when you go outside, if you're painting on the outside of your house, for example, or if you have clothes, okay, it may begin to look a totally different color because now you have other colors, the full spectrum, being reflected off of it, and it may affect the color that it looks like. Okay, and this happens very often in, like I said, clothes, but also on paint samples and things like that. So it's always important to take your paint samples home if you're going to be outside or even in your house under whatever kind of light you have in your house, that you test it under the same kind. Okay, now we're going to try this on this one. We'll see how this works. Okay, we're going to look at a um, clear light bulb first. Now, the clear light bulb is, bend this down a little bit. Okay, let me get it right there. Okay, the clear light bulb is, I don't know what I was going to say. Okay, well, anyhow, we'll try to get this where we can look through it. I don't know. I think I'm going to have to lay it down here and then try to mess with it. Okay, we would expect that to be a fairly white light, so we would expect most of the colors of the spectrum to be there. Not having much luck doing that. Not sure how I did that a minute ago, so we're going to try it one more time here. That's right, maybe I had it flipped over the wrong way. Okay, you can kind of see the spectrum off over here on the right hand side. Not real good there, but for a second there we had it. Okay, but it's kind of like a fluorescent light. It's going to have some bars pretty much through the spectrum. Um, Not the same as natural light on the outside. Now, bug lights are usually yellow colored because bugs are attracted to ultraviolet. They can see ultraviolet, which we can't. Okay. And so they tend to be attracted to that. And so if you have a bug light, you want a light that doesn't have much of that part of the spectrum on it. Okay. So we're going to try to look at this. Oops, there we go. There it was. Okay. If you look at this one, I don't know if you can see it very good. Okay, but try it again. It kind of flicks in there and then goes away. But oh, okay. Anyhow, if you try this, it looks very yellow to you or me, but actually, it is. If you look at it under the spectroscope, you will actually see. There's actually some. It's close, but that's not quite right. Okay. See the slit, but I can't see the other colors. Oh, there we go. Down here in the corner, I saw some. You may not see it very good, but it had some blue, okay, and the violet end of the spectrum, which means it's still going to attract bugs. And so you may have had um, bug lights that did not work very good at all. Now, because they still contain some of those things that attract them. Now, this one is one of the Cooley bulbs, okay, and it also is supposed to be yellow, okay. And let's see if we can line this up so you can see. So close. Just gotta check this out. If you use the spectrometer, because it measures the spectrum, okay, it will actually show if this one is actually all yellow wavelengths of light, okay, and therefore it is going to be a much better bug light because it does not have all the uh, blue and indigo-ish colors of light that the other has, and so this would be a much more effective bug light than the other. Okay, that's about it then for the demonstrations. Sorry, some of these did not work very well on our camera until we get a better camera crew and light meters and sensitive to dark cameras and stuff like that. But anyway, you get kind of the idea of how some of that stuff works. But the color of something depends on the light that reflects from it, and the color of light that can reflect from it depends on what lights are present. Okay, I don't have, apparently I didn't put it in my slideshow yet, but I have two photographs of oranges. Okay, and of these oranges, they're just under regular light. They look, of course, like oranges. Let me see if I can find those real quick, and we'll look at them. All right, here we go. This is just in our house. We could see that there is a jar with, look at lemon drops here, and some candles, and a tablecloth with red and white and yellow, green leaves and stuff. Here's some oranges, yellow, orangey oranges. Okay, some white candle and this. This was with a regular light bulb in the thing here. Now, what I did then is I took and I put a blue light bulb in. Okay, so you can look at it kind of side by side here. Okay, let me move myself out of it. Now all of a sudden, guess what? The oranges look almost black. The yellow lemon drops, since they're yellow, which we know are which colors? Yellow is made out of green and red. So they're reflecting mostly green and red light to our eyes, and so it looks yellow. Notice they look almost black now because now all the only light they have to reflect toward us is blue, they don't have any blue, and so therefore they look black. And same way with the oranges. There's a little bit where they were shiny on top where there's some other colors, so you still see a little bit of light. The white candle just looks blue. The white tablecloth looks blue, but a lot of the leaves that were green and red and things like that, berries, they all look black. Okay, and so basically it depends on what light is available, what color something is. And so literally something is not a particular color, and that's why things can change color under different light, especially if you have fluorescent versus incandescent versus natural lighting and stuff like that. Okay, basically I think that's about it. Once again, make sure you watch all the other videos that go into more detail about some of that stuff. One last thing. I think we went over this in the other one, but I don't think I had these pictures, so I'll show them real quick. These are clouds, okay, obviously. Something, duh. But if someone asks you what color clouds are, most people would probably say, oh, they're white. But if we take a white dot and run it through these clouds, you will notice that it stands out almost anywhere. You can almost lose the white dot in that one because it's pretty white, especially right up there. Okay, it's not very obvious, but you can still see that there's a white thing there. So clouds are not actually white. But when you're in first grade kindergarten, of course, you always say, oh, they're white clouds, white clouds. Well, basically, clouds have little water droplets in them. The little water droplets do the high frequencies reflect high frequencies and or scatter it, which makes bluish color. Okay, you have bigger drops that tend to be on the middle of the spectrum, and then finally you have the bigger drops that do at the bottom of it spectrum, kind of reddish. And so you got different combinations of red, green, and blue, and so you get basically a white-ish cloud, but there's going to be some more of one size or the other, and that's why you get all the different colors. Okay, now once they get stormy like this, that means they're getting ready to rain. That means the drops are getting bigger and bigger, and they're almost big enough to drop. When they start getting that big, they are going to actually absorb the light, and so they get darker, and that's why you see the dark clouds here, and that's why you say rain clouds. Oh, it looks like rain. Well, because the water droplets are getting so big, they're absorbing the light, which makes the cloud dark, and that means that it may eventually get big enough for them to fall, and we have rain. All right. Okay, so really, that's it. That's all. Okay, and we'll see you next time. Don't forget. Since this is Thanksgiving, at least this year, 2022, uh, this is Thanksgiving coming up. Technically, you don't have to turn in your questions till a week from Saturday, the Saturday after Thanksgiving. I would recommend you go ahead and do it and get it done with, but depending on your level of procrastination, you can do whichever you prefer. Okay, and then your quiz will be not obviously during Thanksgiving. It will be open, uh, except for the high school students, but it will be open, but it will not be due until the Monday after, okay? Or Tuesday if you're a high school student, okay? So, anyhow, enjoy your holidays. Either do it before the holidays or after the holidays. It's your choice, but just make sure you get it done. And don't forget, summary articles are coming up. All right, still got a couple weeks. Hey, you got some time during Thanksgiving? Great time to get it done. I'm sure everybody will be doing that. All right, you have a great week, and we'll talk to you later.